welcome to my channel. Today we are going to learn about the matrices from the chapter 3. So in the previous class I have already explained about the matrices introduction. In that I have completed one first exercise. Now in this I am going to explain about multiplications of matrix. So we are going to learn about the matrices, its multiplications. So to multiply two matrices, we have some rules. So what is the rule? For example, if a matrix which is having 2 by 3, its order is a 2 by 3, and B is another matrix, so which is having 3 by 2. So when you do these two matrices first, so we can do. Why we can do these two matrices as multiplication? A into B we can do. So why we can do? In the first matrix it's columns, and in the second matrix number of rows. In the first matrix number of columns, and in the second matrix number of rows are equals, then AT is possible. The product of matrix A and B we can do. And also here is AB equals to AB we can possible. And once check here BA also. So when I write BA, so what is a B? B is equals to here what? 3 into 2, and A is what? 2 into 3. Here number of columns and the number of rows in the first matrix and second matrix are equals. Then BA also possible. So now we can check. These two matrices are equals or not equals. AB and BA are equals or not equals. We will check now. So let us take one example for A. Here I am taking two matrices A and B. So both are having 2 by 2 matrices. Both are having 2 by 2 matrices. It is a 2 by 2 because 2 rows and 2 columns are there, and here also 2 rows and 2 columns there. So number of columns and number of rows are equals. So we can do multiplication AB. So how to do the multiplication? Listen carefully. How to multiply two matrices. So AB I want to do here. So to do the multiplication of AB, first we need to take here first row. First row in this first column. We need to take the first column. So first element is multiplied with 0. So 2 into 0 plus we have to take, and the second element 3 into here second element is a minus 1. Okay, first one is completed. Again this row is multiplied with the second row now. Second row. So 2 into 4 plus 3 into 2 we can take. 3 into 2. Got it? Next second row. Now we are going to write the second row. So in the second row first element is what? 1 into first column in first element. Second row second element into second element here. Okay, and again this row is multiplied with the second column. 1 into 4 plus 2 into 2. Okay, next we can get this answer is equals to AB equals to 2 into 0 is a 0 plus into minus we can get actually here minus 3 ones are 3, and next 2 fours are 8 plus 3 twos are 6, 1 into 0 is a 0 plus into minus 2 ones are 2, 1 fours are 4, 2 twos are 4. Okay now? So and after simplification we can get this answer is minus 3 14 and minus 2 8 we can get the answer. Okay, and next I am going to do here BA. So we got here answer is minus 3 minus 2 4 8. So I am going to write here AB answer. AB equals to minus 3 14 minus 2 8 we got the answer. Now I'll do the reverse. B and I will write first. and A is a 2, 3, 1, 2. So it is also 2 by 2 matrix and it is a 2 by 2 matrix. Got it? Next, number of columns and number of rows are equal. So BA is a possible here. So I will write here BA equals to first row, first column we have to check. 0 into 2 plus 4 into 1. 4 into 1. Next again first row, second column. 0 into 3 plus 4 into 2. Okay. And next second row, first column and second column we have to do. Minus 1 into 2 plus 2 into 1. Next minus 1 into 3 plus 2 into 2. We can get here 0 plus 4 and it is 0 plus 8 and this is minus 2 plus 2 and this is minus 3 plus 4. So after simplifying we can get here this is 4, 8, 0 plus 2 minus 2 is 0 and here we can get 1. So this is answer. And once you observe BA answer is a 4801 but AB equals minus 3, 14, minus 2, 8. We are not getting equals here. AB is not equals to BA. We found one important point is what? AB is not equals to BA. Got it? And next term, some important points of the matrix multiplications. So let us taking here A equals to 2 into 3 and B is equals to 3 into 4. So here is we can do here number of columns and number of rows are equal, so we can do A into B. A into B we can do. But what happens? B is a possible or not? BA is a possible or not? In the previous example I have said, about AB is the AB and BA we can do. Because when you write the reverse also we are getting number of columns and number of rows are equals. But here when I write BA, according to BA first we need to write B 3 into 4 and A is a 2 into 3. So once you observe here, number of columns and number of rows are not equals. So that's why here multiplication BA is not exist. BA is not exist. Got it? And next point. And next point is what? If AB equals to BA equals to 0. So what is mean by 0? It is a null matrix or empty matrix we call it. When you product A and B, when you do the multiplication of A and B, that equals to empty matrix, and B into A, that is also giving empty matrix, nothing but null matrix. So what it means here, AB is equals to null matrix and BA is equals to null matrix. So but we know what, if AB equals to 0 in algebra, we know if AB equals to 0 means we say here A equals to 0 or B equals to 0 we can say here. That means if I say here AB equal to 0, which means if A equals to 0 or B equals to 0, but it is not exist in the matrices. But in algebra it is exist. AB equals to 0 means A equals to 0 or B equals to 0 we can say. But in matrix it is not possible. AB equals to 0 means A equals to 0 or B equals to 0. That means A is an empty matrix or B is an empty matrix. It is not correct. Not necessary to get as an empty matrix. So to say this is, I am going to explain about AB here. So let us going to take here AB matrix. AB matrix I am taking here A and B. When I do multiplication, first 0 into, I said already here, 0 into 3 we can do here, and minus 1 into 0 we can do minus 1 into 0. Next again 0 into 5. Next minus 1 into 0. Next now here is 0 into 3 and 2 into 0 plus 2 into 0 we can write it is 0 into 5 plus 2 into 0 we can write 2 into 0. Once you observe here 0 into something 0 we can get here, and 0 minus 0, 0 minus 0, 0 plus 0, 0 plus 0. So finally you are getting what it is 0 0 0 0. So empty matrix we are getting here. So here is a both A and B are not empty set, empty matrices. A and B are not empty matrices, but when you multiply the matrices, we are getting as empty matrix. We are getting as a empty matrix. So according to algebra, we know AB equals 0. Then A equals 0 or B equals 0 we can say. But in matrices it is not possible. It is not correct. Okay. And next point, we know in algebra AB equals to AC. AB equals to AC if A is not equal to 0. If A is not equal to 0, AB equals to AC means here B equals to C. B equals to C. But in matrix AB equals to AC and A is not a empty set, empty matrix. A is not a empty matrix. It is not a null matrix. But here AB, the product of A matrix and B matrix is equals to product of A and C. So which is not necessary as B equals to C. As B equals to C, it is not necessary to become as a B equals to C. Just like here, A gets cancelled, BC will be left here. So like in matrix is not possible. It is not necessary to come as a B equals to C. So it is sometimes become not equals. Not equals B equals to C. Actually it is a B is not equals to C. And not necessary to get like this. It is not necessary. Okay. B equals C is not possible to get like this. But always we can get B is not equals to C. And next associative property. What is the same associative property? AB into C equals to A of BC we can write here. AB of C equals to A of BC. We can get both left side and right side are equals. So this is called associative property. So multiplication of matrices follows the associative property. And the next one, right side and left side distributive properties are there here. A of B plus C equals to AB plus AC. This is called left distributive law we call this is. And next one, A plus B of C equals to AC plus BC. It is we call right. It is we call right. It is we call right distributive law and it is we call left distributive law. Why we call this is a left distributive law? So A is we are taking left side and BC is the inside. Okay. Which with we are multiplying, which matrix with we are multiplying, that matrix is left side is there. But in this we are multiplying with the C. A and B is multiplying with the C. This C is the right side is there. That's why we call it is a right distributive law and this is we call left distributive law. Multiplication identity is also there in the matrices. Identity of matrix multiplication. If identity matrix is multiplied with A, I into A and A into I, always we can get A only. So if a matrix is if a matrix is multiplied with another matrix to get the same matrix. So that means there is a possibility, identity is there. So that identity matrix I, that is a identity matrix, I into A equals to A into I equals to A. So existence is there here. Matrix multiplication existence for multiplicative identity. Yeah, okay. Next point is what? If you multiply a matrix A into A into A into like n times, if you take here, we can get A power of n. A power of n. So just like A into A, we can write A square. A into A equals to A square. So A into A into A into how many times we are taking? N times we are taking. So we can get the result is A power of n. A power of n. And if A and B are two matrices which are multiplying with two scalars. So like alpha into A and beta into B. When you multiply these two matrices like here, we can write alpha beta of AB, we can write alpha beta of AB, we can write. And also we can say here A into alpha beta of B also we can write. Alpha beta of AB also we can write. A into alpha beta into B also we can write. We can get the same answer. And next up, here is alpha into A whole to the power of n equals to, we can write alpha power of n into A power of n. A power of n. If a matrix, a scalar is multiplying with the matrix and this is having power n times, if I take repeats, so we can get alpha power of n into A power of n. So these are the properties of multiplications of the matrices. So based on matrix multiplication, we have a second exercise 3.2. In that I am taking some questions. So here is some questions are there. 1, 2, 3. These 4 questions I am taking. Here matrix multiplication is exist or not exist, we have to tell here. So to check the matrix multiplication is exist or not exist, we need to first write the order of the given matrices. So we have one row is there and 3 columns are there. And here is 3 rows are there. 1, 2, 3 rows are there and 1 column is there. So number of columns and the number of rows are there. So are equals. These two are equals. So exist. And here is 2 rows and 3 columns. 2 rows and 1, 2, 3 columns are there. And here is 1, 2, 3 rows and 1 column is there. So 3, 3 and the same there. So we can get the resulting matrix. Result matrix order is a 2 into 1. We can write 2 by 1. Here resulting matrix answer is what here? 1 by 1. That means only one element we can get here. Only one element we can get here. Single element we can get. And here is like 2, 1, 4, 6 minus 2 is there. So it is having 3 by 3 and it is a 2 by 3 is there. 2 by 3. So once you observe here, 3 and 2 is there. So there is not exist. Multiplication of these two matrices or not exist. Because here number of columns and the number of rows are not equals. That's why here is not exist. And here is 3 rows, 1 column is there. And here is a 2 rows, 3 columns there. 2 rows and 3 columns are there. Once you observe, this one and this one are not equal. So matrix multiplication is not exist. Next, he asking the question is what if A equals to I0, 0, I, find A square. So what is meant by A square? A square is equals to A into A. So what is A? 2 by 2 matrix, and here A is also 2 by 2 matrix. Because A equals what is there here? I0, 0, I into I0, 0, I. So it is a 2 by 2 and it is also 2 by 2. So number of columns and number of rows are equals. So here is a multiplication is exist. So if multiplication is exist, we have to write like here. First, here is we have to take first row, first column. So I into I square. I will write first I into I, and 0 into I we can get here, plus 0 into 0 we can get, 0 into 0 we can get. Next I into 0 and 0 into I. Next second row, first column, 0 into I plus I into 0. Next 0 into 0 plus I into I. Okay. Next I into I, we know that is I square plus 0, and here is 0 plus 0, because I into 0 0, we can get here 0 plus 0, 0 plus I square we can get here. Yes, we know in the complex numbers I square equals to minus 1. I square equals to minus 1 plus 0, and 0 plus 0 is a 0 only, and it is also 0 only, and 0 plus of minus 1. I square is a minus 1. So we know here minus 1, 0, 0, minus 1 we can get here. So finally minus, when I take common, we can get here 1, 0, 0, 1 we can get. It is what we can say identity matrix, minus I. So finally we got here A square equals to minus I. A square equals to minus I. Yeah, next question. If A equals to 2, 4, minus 1k and A square equals to 0, then find k. So A square equals to 0 is nothing but when you multiply A is multiplied with A only. A matrix is multiplied with itself. We are getting as a null matrix. That time, then what is the value of k asking? So let's see. Here is A square equals to A into A, that equals to 0. Okay, A into A. So what is A? 2, 4 minus 1k. This is a multiply with again 2, 4 minus 1 into k. So null matrix is nothing but 0, 0, 0. We can take it is, because it is a 2 by 2 matrix. It is also 2 by 2. Then answer will be also 2 by 2. Why we can get 1 by 2? 2 by 2. Let's see here. 2 into 2. 2 into 2. Here is number of columns and number of rows are equals. Then resulting matrix is equals to 2 by 2 only. Okay, 2 by 2 we can get here. After getting this, we have to take what? Number of rows and number of columns are equals. Yeah, like we have to do multiplication. First row, first element, first element. 2, 4 into minus 1. And next 2 into 4 and 4 into k plus 4 into k. Next minus 1 into 2 and k into minus 1 plus k into minus 1. Again minus 1 into 4 and k into k plus k into k. Got it? And this is equals to what? 0, 0, 0, 0. But we need to find what is the value, k value we need to find it. So once you observe, it is a 2 2s are 4 and plus into minus 4, and here is 1 2s are 2, that is minus 2, and plus into minus k, and here is a 2 4s are 8 plus 4k, and this is a minus 4 plus k square. So we are getting 0 here, and 0 0 0 0. So once you can observe here, these elements you can take compare, or else you can compare these elements also. Okay, this element we can take equals, and this one are equals. Okay, for this one and this one are equals, and this element and this elements are equals. So I am going to compare. These two elements. What is this? Minus 2 minus k equals to 0. Minus 2 send right side, you can get minus k equals to plus 2. But minus send right side, you can get k equals to minus 2. This is the value of k. Required value of k equals to minus 2. And you can check in this also. 8 plus 4k equals 0 also you can take it. 8 plus 4k equals 0 actually. This value we have to compare. 8 sent to the right side. You can get minus 8 and 4 1 the 4 2s are. In this case also we are getting the same value. Okay.